Let's start then.
Yeah. So we will be covering equations, inequalities, and graphs, and then we will be doing logarithmic and exponential functions next chapter. So first thing you need to know about when you're solving inequalities, you need to know the term modulus. So we studied in functions. So you need to solve inequalities involving functions. So there can be these four types mainly. So modulus of ax plus b greater than or equal to or less than or equal to c, where c is not equal to 0. So you know these types, right? Like mainly these are the four categories you can separate this kind of questions. And modulus of ax plus b is greater than or less than or equal to cx plus d modulus. Without modulus, then cx plus d. Then you have modulus ax squared plus bx plus c greater than or equal to or less than or equal to d.
What what
And
is what is
this
like what really is this? Like this is
these are
just
like the different categories of questions you can get. Like a can be or a can be an integer, b can be an integer. Like when you're solving these inequalities, these are the various types of questions you can get. So like they ask solve. We'll just see an example here. One second.
yeah.
Yeah, like these kind of questions. So like I just categorized in different types or so that it's easier for students to get the hang of it or know what might come.
Hmm.
So
Okay.
maybe you can just try. So there are two ways of solving, either by squaring both sides, or you can do the normal method, like you take 2 times x plus 3 and 2 times negative of x plus 3. That method also. But you need to be careful with the sign. So the sign is the important thing. When
Could
you're
you
adding a yeah.
yeah, could you explain me like both methods? I know the square method, but this method I'm a bit doubtful with because like won't there be
Okay.
four scenarios?
Okay, so what happens is, for let's take this question. Okay, so x plus 1. Yeah, there should be four values because there are two modulus here. So
Yeah.
first you can take x plus 1 is greater than 2 times x plus 3, or you can take x plus 1 less than 2 times negative x negative 3. You know how I
Why?
got this less sign? So the whenever you're multiplying, so the rule is whenever you're multiplying any inequality with a negative number, negative integer. So let's say negative k. When you're multiplying with a negative integer, any of the inequalities, the sign would change. So
Oh,
multiplying and dividing will make the sign change. Adding and subtracting doesn't make the sign change. Because when
oh,
you're drawing or sketching the graph, right? So the whole thing reflects on the other side. So that's why it's less than or greater than. So that's the main difference between the both.
okay.
So then either this or then you can have x plus sorry you can have negative x plus 1 negative x plus 1, then this will be the less than 2 times x plus 3, or you can have negative x plus 1 greater than negative 2 times x plus 3. So you can just multiply this negative 2 inside, so that's not a matter. So these are the four terms you will get, and then sometimes you might need to go cancel some of the terms because they are not real numbers or they won't be satisfying the equation when you substitute into it. So
Right.
so then you need to check with that also, like if it is matching with the inequality. If it's not matching, then you cannot use it as an answer.
Right.
So then you know the squaring method, right? I'll just do it for the recording purposes once. So here you just square the x plus 1 and greater than 4 times x plus 3 squared, because 2 squared is 4. I just write it as 4. And then you can solve it as such using a quadratic function. Then you can find the roots of the quadratics and then you can change you can draw the quadratic like this, and then find the range. Like if it's greater than or less than, you can just shade the. If it's greater than, you can shade the top part. If it's less than, this part. So you can just find the range with that range of values of x. Got it?
Got it. Could you solve it once for me? Like using the modulus method.
Okay.
Square method is easy. The modulus method, I'm not at all.
The
Like,
normal, the four equations method we used, right? That one.
yeah, that one.
Okay. So as we saw, first is x plus 1 greater than 2 times x plus 3. So you expand it, x plus 1 greater than 2x plus 6, and then you can convert this here. So x is less than negative 5. Got it?
Okay.
So this is
Wait,
one of the solutions. Then you
that's
can,
the
yeah.
that's the answer.
No, this is one of the answers. So you need to check by substituting any number less than negative 5 into this, and then checking if it's matching. So then you can do the checking by your own. I'll just do the solving.
What are the other two equations? Yeah.
So the other two equations are x plus 1 less than negative 2 times x plus 3. Negative times x plus 1 will be greater than negative 2 times x plus 3. Negative x plus 1 is less than 2 times x plus 3. So these are the four equations. So this is equation number 1, this is equation number 2, this is 3, and this is 4. You need to solve each of the 4 and then check with the range if it's matching in this.
Okay, so for this first one's x is less than -5. Second one would
Yeah.
be the won't it be
So
wait
here maybe I'll just solve the second equation here. So x plus 1 negative 2x minus 6, then you can have 3x less than 1
mi
minus
minus
7, and x is less than negative 7 over 3. So then you need to check if any number less than 7 over 3 suits this equation, and if it's suitable, then you can use it. You can write the answer as that. And sometimes if there are two equations, so you can see that x is less than negative 5, x is less than 7 by 3. So what does this mean when you draw a number line? So 7 by 3 is 7 by 3 is greater than negative 5, right? So
mm,
when you're drawing the number line, let's say if this is 0, you have negative 7 by 3 here and then negative 5 here. So when you draw the x value, it will move towards here, and this also moves towards here. Any number less than that. So what does this ultimately mean is any number less than negative 5 can suit it. You don't need to write this as the answer also. You can just write x is less than negative 5, because within negative 5 is only negative 7 by 3. Got it?
yeah.
Or you
Um,
want me to explain it again?
I mean I get it, but I'm more concerned about so the other two equations, the minus x ones, third and fourth equation, then what you don't need to use them at all.
No, you need to solve both of them and then check in the number line if it is either, like if it is a positive number, let's say, and it is like 1 and then 2, okay? X is greater than 1 or 1 and x is greater than 2. I'm just giving a hypothetical value, it's not the actual answer. So
Hmm.
you need to now see both if even x is greater than 1 or x is greater than 2 ultimately means x is greater than 2, because any
Right.
number less than 2 will not suit, and any number greater than 1 or 1 will ultimately match with the x is greater than 2. So you can just write one of the answers should be x is greater than 2, because it's 1 is already within the 2.
Yeah, okay. And I get that. And square method would be x square plus 2x plus 1 is greater than x square plus 6x plus 9. So
Yeah.
I want to put all this to one side, right?
Yeah, you put it on one side and the other side will be 0 and then solve the quadratic. Then you can draw the graph and then check which range is it from, like which of the range of x is matching with the equation.
Uh, so in this square method, right? So if I move
Yeah,
x squared to the other side, won't it cancel out?
yeah, wait once. Yeah, it should cancel out. Yeah, x square will cancel out. Then you can find, sometimes there might be, since here it is two times, you can see two times, right? 2x squared or 4x squared won't
Yeah.
cancel out. So yeah, so maybe I'll just do the squaring also. You want me to do it, or we can
Uh,
move
I'm
on?
just I'm just attempting it. Give me a minute.
Okay. So like what I would recommend, like if there are two modulus in both the sides, go with the squaring method because it won't leave you any of the answers. When you do the normal method, right, sometimes you might leave some of the equation and then you won't be able to solve it fully.
Okay. Can you just show me how to solve it once I'm doing it now?
Yeah, it's the squaring method.
Yeah.
Okay, so you square both sides as usual. Wait, let me use the so x plus 1 squared greater than 2 squared and then x plus 3 squared. So x squared plus 2x plus 1 is greater than 4 times x squared plus 6x plus 9. And then you get x squared plus 2x plus 1 greater than 4x squared plus 24x plus 36. So then you can move the left hand side to the right because it's easier. So then you will get 3x squared plus 22x plus 35 is greater than 0. No, less than 0, sorry. It should be less than 0. Then you can solve this. So then 35, wait, let me do it with my calculator. Let's 30.
You can just put in the calculator. I mean
Yeah,
now,
so
but there's non-calc exams now, so
no, that because here it's a fraction answer, so it's mostly they won't ask you if you want. If it's a non-calculator, then you can use. You need to do it manually only.
is this can you
But
split them
most
in?
of the questions in non-calc paper will be whole numbers answers.
Yeah, but in this one, is
Yeah.
there any thing like is there any uh
1 second, I'll just be back. Yeah, tell me.
yeah, one answer is -7/3, one answer is -5.
Yeah, okay. So you got -7/3 and -5, right?
Yeah, so x plus 7/3 into x plus 5.
Okay, then the other two equations are invalid to this question. So these are the only two answers. So then okay, wait, let me just write it in factorized form. 3x plus 7 and then x plus 5 is
Are you
less
sure
than.
you can't midterm split this?
Yeah, you can. This is how you split it.
No, but like I don't have to use a calc. Like manually, is it possible to do this? Like without
Yeah,
using the
then you need to check
formula.
35 times 3 and then factorize this. So you get 15 ones, 3 threes are 9, 10. So factorize 105 and then check if the sum matches 22.
Right, so 105.
So then it will be 5, 21, 7, 3. So then 7 5s are, okay, 5 threes are 15 plus 7 is 22.
Yeah, so 3x square plus
3x.
7x plus 15x plus
Keep
35.
15 for 3x squared. You can factorize that easily.
Yeah, 3x squared plus 15x plus 7x plus 35. 3x x plus 5 plus 7 x plus 5 So 3x plus 7 and then x plus 5.
Yeah,
Yeah.
that's what we got here.
So 3x is, so x is minus 7 by
So
3.
now what you do is, okay, you don't need to write that. Okay, so an easier method is to sketch this graph. So the quadratic just will be this upside down curve. So then the two roots will be -5 and -7 by 3, right?
Yeah.
So and this whole graph should be less than 0. So the numbers less than 0 for y value will be this part.
Yeah.
So
Because
it's
this is a,
between -5 and -7 by 3. So the answer will be -5 less than x is less than -7 by 3.
okay, I got it.
So go with this graphical method so it's easier for you to visualize and solve it faster.
Definitely. Yep.
Yeah.
Okay. All right. Thank you. Now, substitution.
So substitution for quadratics. On first lecture we saw about quadratics, but here it's something tricky. You need to first form the quadratic before you solve it. So
Yeah, I know.
here you know this, right? So like
Two. So this is like it's going to be x y square plus y minus 12 is equal to 0.
so you need to let y be x2
Yeah,
by 3, and then
x2
it will
by.
be y squared plus y minus 12 equals to
Equal.
0,
Yep.
and then you can
Minus,
solve this.
you can do minus 4 and 3, my 4 and negative 3. So y
Yeah,
square plus
so
4y minus 3y minus 12.
y plus 4, y minus 3 equals to 0. Then
Yeah.
you get y equals to -4, y equals to 3. Substitute x2 by 3 into -4, and x2 by 3 equals to 3. And then you can solve it using logarithms, or you can do the other way around also. Like, so x will be negative.
Um, wait, how do you do that?
It
So,
should be root of 2 by 3 -4,
root
because
of,
x. Okay, that won't. Okay, so this is invalid because negative. You cannot have a negative for 3, right?
yeah.
So this will be not a valid answer. Then you can
Because,
have
wait,
2
what's the
by.
reasoning?
Huh?
What's the reasoning that can't be valid?
Because when you convert this, -4 cannot be in the square value. So say, you need to first square -4.
Ah,
So it's so like the when you root a negative number, it won't be valid, right? So that's why you cube root this. Okay, wait. So if you cube root and -4 squared, yeah, I think it would be. Wait, I think I made a mistake.
yeah, that's what I'm saying. 16,
Cube
cube,
16. It should be a cube 16. Cube root of 16, which is about 2.52. And then
right.
this one would be x is equal to cube of 3 squared, which is 9, which is about 2.08. Got it?
Yeah.
So
So
yeah,
I
this
have to use logarithm in this, right? Like, so
you
what do you need?
it's not actually logarithm. So because the base is what you need to find. If you need to find the exponent only, you need to use logarithms.
So wait, over here, it was x to the power 2 by 3, right? So that means
Yeah.
minus 4 to the power 2 by 3 is equal to x. Is
So
that what you
come
done?
again. I
I don't get what you've done after x to the power 2 by 3 is equal to minus 4.
Okay. What is x2 by 3? How can you write this? X
Um,
squared and then 1
yeah,
by 3. Agreed?
yeah.
So you move this 1 by 3 on the other side for -4, which is cube root of -4.
But if I move cube root to the other side, won't it be cubing it? If you move a cube root to the other side, it'll cube, no?
You're not you moving the cube root. You're moving 1/3, right?
Wait, so if I move 1 by 3, then what will happen?
Yeah, well, let me just erase this. It's a little messy. 1 second. Okay, so x what we got x2/3 -4 and x2/3 equals to 3, right? So these were the values we got from the answer. So then what you do, okay, wait, yeah, I think you're correct. Okay, sorry. The 3 should be on the top, so it should be the exponent and then square root. Sorry, yeah, that's why it was invalid.
Wait, what? No, but then it won't be 3 by 2, not 2 by 3. What you did
Yeah,
before
so
was
okay, you know that x squared 1/3 is x2/3, right?
yeah.
So then 1/3 is basically a cube rooting the x squared, cube root x squared. If you move the cube root to the other side, it will be -4 cube,
Right, yeah, that's what I was saying. Yeah.
and then you get square root because x squared, then you move square there, square root, which makes this invalid. Yeah, I was correct last time. Sorry,
So minus 4
it is the
cube,
other way around. Yeah.
it's negative. Oh, yeah, okay.
So that's why it's invalid because -64 square root you cannot do it.
Yeah, yeah, okay.
And then this one, this is basically x squared 1/3. So then you do cube root of 3.
No, we'll do
No,
cube
no,
of 3.
3. Okay, 3 cube. Sorry, 3 cube, and then you do the square root. Got it? So it will be 3. It should be 27.
Equal to
Square root
3.
of 27.
Yeah, square root
So
of
this is the
27.
answer. So you just exclude this one. So only square root of 27 will be the answer.
Yeah, okay, I got it.
Yeah. Sorry about the thing. I
No worries.
interchanged the thing. Yeah.
Even I messed up, yeah. I think I confused you.
Okay. Now sketching of more quadratics. So you need to sketch graphs of quadratics and its moduli. So you can see a modulus graph here. So 2x squared plus 3x plus 5. Have you learned this like from yourself or you want?
Um, I'll just try the question.
Yeah, maybe you can just try first before we move to the solution.
Oh, I'll just have to sketch this and then
Yeah,
flip it.
sketch this graph. So like maybe I'll just try it because you cannot show me the sketching. I'll
Right,
just
but
do it here.
I think for this question I'll have to use a calci if I want to make the points.
No, what if this comes in non-calc? Then what? Because
Then
this gives you an integer root.
okay. So 10.
Wait, let me
Okay.
check if it's integer root just to clarify. Uh, it should
It's
be
10.
minus 3x, sorry, minus 3x. Then it would
Oh,
be, no,
then it could be.
no, then also it doesn't come. Wait, what?
It can't be
The wrong
minus
x.
3.
Oh yeah, it should be minus 3 minus 5, sorry, sorry.
Oh,
Because
okay.
I took the other way around. So it should not be plus, it
Then
should be
minus 5 and
minus.
2. Minus 5 and 2.
No, the answer, then you will get, the x will be -1 and x would be 5/2.
Hmm? Um,
2x squared minus 3x minus 5 equals to 0. If you take 10, so 10 will be 5 and 2. 2x squared plus 2x minus 5x minus 5. Then you do 2x times x plus 1 minus 5x plus 1. Then you get 2x minus 5 x plus 1 equals to 0. So the roots are x is equal to -1 and x is equal to 5/2.
yeah, I got that.
So then you just sketch those points. So like 5 by 2, maybe let's say here, and
Yeah.
-1 would be here. And
Right.
then when you're drawing the curve,
So it'll just be like
and then
it's
you
like
need to know the y-intercept also because see here the y-intercept will be -5, -5
how come? Yeah, yeah, it'll be -5. Yeah.
because the c is this. So yeah,
Yeah, I got that. I got that. So this will be
and then
positive
you
5.
just sketch it.
Positive 5. Yeah.
And then since it's a modulus, you need to convert this part, so this part upside to the top because all the values will be positive, right? As in a
Yeah, I got.
modulus.
Yeah, I got this.
Yeah. So then you draw this as like this, and then make sure this bottom part, if you're drawing it, it should be dotted lines. So
Right.
like,
Okay.
yeah. So it should be like this, and then dotted goes, and then you draw this.
Right.
Yeah.
Okay.
So then similar to that, there's cubics. You need to know how to draw cubic graphs. I won't do the exact like the values. I'll just show you the shape, how it looks. Maybe that then you can just sketch the points and then do it by yourself. So this cubic graph would look like something like this, right?
Yeah.
So then the moduli would be this part will be on the top. So this part goes like this.
No,
Got
for
it?
this question, this can this ever come in non-calc?
If it comes in non-cal, mostly it won't because cubics graphs like there are the solutions can be a lot. So there are three solutions you need to find. But they might ask you as a follow-up question of first you need to solve this for 6 marks using you saw yesterday's video, right? Like using the factors of polynomials, you need to find at least one factor, then make it into a quadratic and a linear,
No,
a
just
product
wait.
of.
Can I try this? To solve it, I can use synthesis, right? Synthesis division.
Yeah, maybe you can just solve this if you want. Yeah, one second, I'll
So
just.
solving, I'll use division, right? I don't think there's any other way.
First, you need to find a factor, the linear factor before you divide. What will you divide with?
Okay, so linear factor clay. Um,
You just need to see which is the linear factor that comes here. So
so
one,
how would I do that?
mostly it will come in calculator because you need to write a lot and then
So, but how would I
because
solve it
I'm
first?
using a calculator right now just to find the one of the linear factor. If it comes right, I think
Could you help me finding it without a calculator? Find one factor and then
then you
divide
need
it.
to do it only manually. You need to punch in the numbers inside, like let's say -2, -1, or one of the ways you can reduce the number of tries, right, is to see this. So any positive number you put in this, the answer will be positive because all are adding, right?
Hmm.
So it should be at least a negative. It should be only a negative number, some negative number that cancels out to become zero. So you can start with -1, and if it doesn't work, go to -2, -3. Mostly in non-calc, they won't give more than -3. So only within -1 to 3 you can find out. -3 to 3. Okay, so
But
-3 to +3.
I still don't know how to attempt this question. So to attempt this, what I do is I do trial and error basically.
Yeah, for first finding the first factor, you need trial and error. Then you can do the long division with the first factor and then find the quadratic factor. Then you can do the quadratic factorization to find all the three linear factors.
Okay, is this like trial and errorable?
Okay,
Let's
let me
try.
just do it. So we would be solving it. Okay, let's just do the solving part of y equals to x cubed square plus 2x plus 6 -2. The other way you can do if it's a calculator paper, you can just use the polynomial function in the calculator. You know
Yeah.
that, right?
Solve one, right?
Okay, so the one of the factors is x plus 3. Okay,
Right.
when I do the factor theorem with x is equal to negative 3, I get a 0.
Okay,
So
okay.
x plus 3 is one of the factors. So this is a
Then
factor.
I know.
Yeah, then you can just do the long division x cubed plus 3x squared plus 2x plus 6. Divide this by x plus 3. So x squared, x cubed.
X square plus it's literally x square plus 2.
Yeah, x squared plus 2.
Yeah.
So
Do
then
you use synthesis division or do you use long division for your answers?
synthesis division is not part of the additional math syllabus. So like for now they have removed it. I don't know about the previous year papers.
So if I do it in my exam, I won't get marks.
Yeah, for the steps you won't get marks. You will get only for the answer. So may better to stick with long division
I'll have to
because they
revise.
won't see you they won't see the way you do it. They only see the factors you find. So the only the factors you find gets the marks.
So I can do that with synthesis still.
Yeah, you can do it as a rough work to check. Maybe that would be rough work. So you can do that to check if your answers are correct again. But I think it would be better to go with long division.
And then I'll have to revise that. It was in the video yesterday, right?
Yeah, yesterday's video it was there.
Okay.
3x squared plus 2x plus 6. Okay, we did that division, sorry. So then you get x plus 3, x squared plus 2.
Yeah.
So now x squared plus 2, you cannot divide it further. So then
Yeah.
you just leave it as that. So then x is equal to negative 3, x equals to, okay, only x equals to negative 3 will come. The other two are imaginary root. I just took this. Mostly they won't give you like this imaginary roots. It all be real roots. I just took this from search, so Google. So I don't know. I didn't know the answer before.
Hmm.
So you understood the sketching also, right? Like how to do the modulus and the normal sketch.
Yeah, we just need the x-intercepts and then the
Yeah,
we
yeah.
can just okay.
So then another topic is to solve inequalities graphically. So graphically, as in, okay, let's just see. So how to solve inequalities without the algebraic method, like we did, like squaring or doing the other one. So to do graphically, you need to draw these, draw the two graphs in one, draw the two axes and then draw the graph and see where it intersects depending on the sign. So here it is less than, greater than, so it should be on the greater hand side.
Hmm.
Got it?
Yeah, so to solve this, I'll do x plus 1. Can I square? Do the squaring method?
No, this is graph. You need to use the graph to solve it. You need to draw the graph first, then check if it is greater than, you shade the area of the greater hand side. So
Okay, this is
here for, since 2x plus 3, for the greatest will be this side. So I shaded this as green.
yeah. Okay, this is easy.
Yeah, this is a more straightforward way, but to find this point, the intersection point, mostly these kind of questions will have real roots. So like it will intersect at one, negative one. So it all will be integers. No, like not a fractional number.
If
If
I
they
want to
ask
solve
any
this,
kind of questions.
if I want to solve this algebraically, how do you do that?
How? Sorry.
Algebraically, like without a graph.
Algebraically. Okay, then you do the squaring method. X plus square 4 is greater than 4 times x plus 3 squared, and then solve it. Solve the two sides.
Okay.
And then check with the graphs I told you, the quadratic curve, if it's within this range or outside the range. Not.
Okay. Yeah. Yeah, I got it.
Yeah, I think we're done with equations, inequalities, and graphs. Now we'll move on to logarithmic and exponential. So, what are logarithms? First, let me ask you this because this is a very important thing to understand before we jump into logarithmic functions. Do you know like what is the basis of logarithms and how it
Yeah.
is
It's basically to like find the exponent, like, and it's log. I know like log a to the base this. So basically, it's to raise something to the log power, is to get that number, right?
basically you can tell this it is the inverse of any exponential function or exponent.
Right.
So it's whatever you do with the exponent, you do the other way around. So if you since exponent means repeated
Right.
multiplication, this is repeated division.
Right. Right.
Logarithms is repeated division. Repeated
Okay.
division. Okay, so you need to understand these three facts. So logarithms to any base. So first, if they give you log a as generally, or some questions tell you LGA. So LG or log a, just log means it's to the base 10. So because conventionally we use the decimal base 10 for any of the questions or the in yeah. So you understood this, right? Like this
Yeah. Yeah.
convention of log a. And then
Yeah.
log any base to 1 will be 0. So log 1 anything to the any base can k for any base will be 0. And
Okay.
then
Yeah.
log to any base to 0 will be undefined
Okay.
because you cannot divide 0 again and again by any number.
Right.
You will get the same and if this is a 0, then it will be undefined as such. So repeated division cannot be you cannot occur with 0. So only with other than 0 you can do it.
Okay. Yeah.
So then these are some laws here. So as we saw, logarithms are the inverse of exponents, and the laws are here. So for first is the product rule. So the product rule states that log ka plus log kb will equals to log kab. So if you're adding any two logarithms to the same base,
Hmm.
uh, you can multiply them like this. So like you can multiply the a and b, and then you can make it into one form. So
Right.
then quotient rule is also similar. If you're subtracting with the same base any two numbers, then you can divide it like this a by b.
Okay.
So then reciprocal is basically you
Ba-
interchange the
base.
basis and the exponent. So if log
This is
ka is equal to 1 over log ak.
the base change rule, right?
This is a reciprocal rule. Yeah, you can use this for base change also. So this is where the base change comes in, from where you get it. So
Yeah.
the basis of change of base is this. So if you reciprocate, then you can change the base and the number which is there.
Hmm.
And then we have log to the same base and power. So log a, so same base and same power, you will get 1. So because dividing it by the same time, you can do it only once. So like a divided by a is 1. So that's
Yeah.
what this means. And then the power rule. So log k a to the n, you can bring the n to you can multiply this by n itself. So like you take, if you have log,
Yeah. I know this one.
let's say, yeah, log 3 6 squared, you can bring the 2 down and then log 3 6.
Yeah. Okay.
So then change of base, as you told, you can change the base by dividing the exponent power and then the base.
Okay.
So then this is a one-to-one property. So this is basically telling you if log bx equals to log by. So the base is same, You can equate the x power.
Yeah, okay, this is pretty simple, yeah.
Yeah.
Okay.
Okay. Now maybe you can just try a question before we move on to the next topic.
Okay. I have a question. Will the two stay there?
Which two you're talking? This one.
Yeah, it's gonna be 2 log 2 x plus 15 by x.
Okay. Since the hint here is to make it into a quadratic equation, right?
Hmm.
So the hint is you can move this 2 to the exponent, x plus 15 squared. Then
Okay.
you can do the division.
So,
Because you need to remove the logs from the whole thing. So you make it to the same log. 2 log 2 and log 2 are different. So yeah.
but log 2 x plus 15 is different from log 2 x, no?
No, so wait, okay, the base is same. I'm not talking about the power.
Hmm.
So the base is same here. So you can just make the squared here minus log 2 x equals to 6, right?
Yeah.
So now what you can do is log 2 x x square plus 30x plus 225 by x equals to 6. Now you can move this log 2 here. You will get 2 to the power 6.
But wait, what? If I move the log 2 there, 2 to the power 6.
So you move log 2 to the right hand side. What you will do?
Yeah.
So you do x square plus 30x plus 225 over x will be 2 to the power 6 because the base is 2. You're raising it to the sixth power.
Right.
So then 2 to the 6 will be what? 64, I believe. Yeah, 64. So then you write x square plus 30x plus 225 equals to 64x. You move the x to the right and then you can multiply. And then you can minus this here. So x square minus 34x plus 225 equals to
Okay.
0. We got the answer.
Okay, and now it's asking us to solve it.
So you know
Solve
the
the
rule, right? How to do it.
so solve the equation right now.
So solve the equation as in you need to solve for x. So you can just solve it using this quadratic.
Yeah, so what this factor out is my thing. Um,
I think it's better you do. Okay, so 225. Wait, let me check. I think it will be a decimal number. 225. No, it is a whole number only. 25 and 9. X is equal to 25 and x is equal to 9.
okay, so it must be x square minus 25x minus 9x plus
So you need to
225.
know that 25 times 9 is 225, and then you can put,
I mean, yeah, you can make that out pretty
yeah,
easily.
that's easy. You can factorize it and then do it.
X
Shall we move
minus
on?
equal to
Or
9, x equal to 25. Yeah, okay, got it. Thank you. Yeah,
okay, now a different type of question. So this is
okay. What is GP? Oh, LG, LG. Okay.
LG. It's LG. So
Yeah, 3 plus 2,
it's not
1.